Good afternoon. Today we are going to see the problems on equilibrium. And in this video, we are going to see the questions that is from January 2023. So we have solved questions from last 3 question papers, that is 2019 December, I can say. Then July 2022, and now we are with January 2023. So now to see the videos on this engineering mechanics, you have to go to Civil Engineers Technical Hub. In that you can have this playlist in which you have engineering mechanics. And then you can come across videos in this playlist. So now we will go with question, that is a 20 kg homogeneous smooth sphere rests on two inclinations at 75 degree and 30 degree as shown in figure. Calculate the contact forces at A and B. Already I have explained now. So we have perpendicular to this. So this angle is 90 degree. If you extend this line, then you will come to know angle made by, if I will say this as A and this contact is B, then angle made by reaction RA with horizontal will be 15 degrees. And if we will plot here, so that will be RB. This angle is given 30 degrees, this is 90 degrees, so this angle will be 60 degrees. So we have, now if I will plot this, then we have this as angle made, this was 15 degree. RA. Then we have another making angle 60 degrees, which will be RB. And then we have weight, that is 20 into 9.81. 20 into 9.81. So now we will go to equilibrium equation. So we have first equation, summation fx equal to 0. Then we have RA cos 15 minus RB cos 60, that is equal to 0. Then we can have another equation. So this will be equation number 1. Then we have summation Fy equal to 0. We have RA sin 15 plus RB sin 60 minus 20 into 9.81 equal to 0. And from this I will get another equation, RA sin 15 plus RB sin 60, and that is equal to 20 into 9.81. This will be 2. So now we have to solve this. So solving equations 1 and 2, we get value of RA, we have 101.56 Newton, and RB we have 196.2 Newtons. Now we can solve this by using Lami's theorem. So I have this as RA making angle 15 degrees, weight acting downward 20 into 9.81, and then we have this angle 60 degrees, which is of RB, So this angle we have 60 degrees. So now if you calculate this angle, so 180 minus 60, 120 minus 15, 105 degree. This total angle becomes 150 degrees. And this angle again becomes 105 degrees. And then we will get RB upon sine 105 equal to RA upon sine 150, which is equal to 20 into 9.81 divided by sine of 105. And therefore we will get value of RB is equal to 196.2 Newton and RA equal to 101.56 Newtons. So we have these values of RA and RB, which we can calculate by using Lamy's theorem, or we will calculate it by using equilibrium equations. Now explain how uniformly distributed load and uniformly varying load is converted into a point load with sketch. So now I will consider a uniformly distributed load. So let we have this as 4 meters. And this uniformly distributed load, let us we have 50 kilonewton per meter. This is first we are explaining UDL. So now when we will calculate point load, so we have area of this, height we have this as 50 and length we have 4. So total we have 200 and that will act at center. 50 into 4 equal to 200 kilonewton and that will be at 2 meter, that is at center. Now if we will go to UVL, uniformly varying load, then we have this will be triangle. So let us, we have this as a triangular load and this value we have, let us 75 kilonewton per meter. And this, let us, I will say 3 meters. So it varies from 0 to 75 kilonewton per meter. So now we have to find point load for this. So we have to find total load. What will be total load of this? 1/2 base into height. So we have total load, which is considered as point load, equal to area of load diagram, 1/2 into 3 into 75. 1/2 base into height. And then we will get it as 225 upon 2, which will be 112.5 kilonewtons, where it will act. CG of this triangle is at h by 3 from this. Means we have centroid of this triangle. This will be 1/3 of 3 and that is 1 meter. And therefore, concentrated load will be considered at 1 meter from right or 2 meter from left, having value 112.5 kilonewtons. So likewise, we can convert it into a point load only for the purpose of taking moment. Then we have next problem that is from same question paper. So we have given determine the support reaction at A and pinpoint B for beam loaded and supported as shown in figure. Now we have here reaction as VA. Then here we have reaction as VB. Now our HB is 0 because no horizontal load is there. We have parallel force system. So we should have 2 unknowns. So now total weight, this is acting at the center of this box. and that is 300 into 9.81 Newton. 81 newtons. So now I will draw free body diagram of this. So we have VA. Now I will just plot this. So we have this as VA. Then we have this as VB. Then 2.4 meter and 1.2 meter. There our load is acting. You can show up or you can show down. It is downward only. So 300 into 9.81. 1.2 meter from this side and 2.4 meter from this side. So just check it. And then we can solve this. We will take moment about A equal to 0. And we have 300 into 9.81. This will be my force. And distance is 2.4 minus VB into 3.6 equal to 0. And from this, we will get value of VB 1962 newtons. Therefore, VB equal to 1962 newtons. Now, if we will apply Fy0, so we have summation Fy equal to 0, then we have Va minus 300 into 9.81. Now VB we have 1962 newtons. So minus 1962 equal to 0. And therefore we have VA that is equal to 981 newtons. So VB 1962 and VA we have 981 newtons. So likewise, we have to solve these problems related with equilibrium. Then we have explained simple, roller, hinge and fixed. Already I explained. Now here given simple and hinge. So actually simple, some books are saying like this, 2 reactions and hinge. So this is we are using for fixed, and we have that is dot inside, and then here also we have 2 reactions only. So you can write this as simple. Sorry, you can write this as simple, and you can write this as hinge. Actually, both have same reactions. Then roller already we have mentioned. We have only one perpendicular to the support, and fixed we have 3. That is 2 reactions perpendicular to each other and 1 moment. So likewise, we have to solve the problems in examination. So if you have not subscribed, subscribe this channel, Civil Engineers Technical Hub. Now we will stop here only. Thank you.